वो 2D इमेज पॉइंट पे मैप कैसे होता है, उसकी इंटेंसिटी कितनी रिकॉर्ड होती है, दैट इज द लाइट रिफ्लेक्शन प्रॉपर्टी ऑफ द पॉइंट। वी आर इंटरेस्टेड इन कि वो किस पोजीशन पे रिकॉर्ड होता है। और इसकी वजह मैंने आपको लास्ट टाइम भी बताई थी, वी विल अंडरस्टैंड द प्रोसेस ऑफ इमेजिंग to understand how the process can be reverted in a way. So to understand how to do the 3D reconstruction, let's understand how 3D is mapped to 2D. Make sense? So I'm assuming here, for example, these points, they emit rays. For example, this point is emitting a ray, light ray. It passes through pinhole and hits the image plane somewhere. ओके इस प्लेन को ये जिस जगह पे हिट करती है, प्लेन का कोई अपना ओरिजिन होगा, प्लेन का कोई अपना ओरिजिन होगा, इस प्लेन का which is called image plane, इसका कोई अपना ओरिजिन है, इसके तो अपने x एक्सिस और y एक्सिस है, 2 एक्सिस होते हैं। उस अपने ओरिजिन के लिहाज से और इसके अपने एक्सिस के लिहाज से इस पॉइंट के कोऑर्डिनेट्स क्या हैं इस प्लेन के अंदर। Similarly, this point it will be having different coordinates, this point it will be having different coordinates and so on. So the goal is, given a point in 3D, given the location of the point in 3 dimensions and the focal length of the camera, अगर कैमरा की focal length मुझे बताओ, where this point in 3D will map to 2D. Make sense? That's how we do it. Assumptions. कैमरा का जो pinhole है, which is the camera center, this acts as origin. So the coordinates of this camera center is 0, 0, 0. कैमरा का अपना एक coordinate system है, which is x-axis of the camera, y-axis of the camera, and z-axis which is coming out of the camera. ये जो z-axis है, it is completely orthogonal to the image plane, and this z-axis is sometimes called optical axis. ये जो optical axis है, which is orthogonal to the image plane, passes through the image center, passes through the camera center. ये जिस जगह पे जाके image plane को intersect करता है, that point is image origin, sometimes called principal point. So this is just a terminology that you want to use.
ये origin की समझ नहीं आई?
Origin of image?
Yes sir.
Origin of image is where this optical axis intersects the image plane.
Optical axis sir कैसे decide हो रही है?
Optical axis is the axis that it is a line that passes through the pinhole and it is orthogonal to the image plane. So, in particular, अगर आप यहाँ पे देखें, सभी, if you see here, this is the axis that passes through the camera center, and it is orthogonal to the image plane. And it hits the image plane at this point. This is the image origin. Clear?
Yes.
Okay. So camera has its own x, y, and z axis visible here. This is the x-axis of the camera. This is by the way pinhole. This is x-axis of the camera. ये मैंने तस्वीर कहीं से कॉपी की है, x1 लिखा हुआ था, y की जगह पे x2 लिखा हुआ था, z की जगह पे x3 लिखा हुआ था. So मैं उसको edit नहीं कर रहा है, so I just so this is x-axis of the camera. This is y-axis of the camera. This plane x, y plane of the camera, the image plane is completely parallel to it. See, and it is shifted f units away from the center. And this z-axis is orthogonal to xy plane, and this z-axis, if it passes through the origin, this is optical axis, and it hits the plane there. This is the image origin. The image x-axis and y-axis. This image plane has x-axis, which is completely aligned with the camera x-axis. The image y-axis is completely aligned with the camera y-axis, and there is no z-axis of the plane because plane is a 2D structure.
Yes.
Yes, no?
Yes.
Okay. Now the goal is, considering pinhole as origin 0, 0, 0, and considering x-axis, y-axis, and z-axis of the camera to be the coordinate system from which we measure the 3D world, and considering these points इनके 3D coordinates, x coordinate, y coordinate, z coordinate, they are available in the camera coordinate system. So मैं assume कर रहा हूँ कि कोई 3D में point है जिसके coordinates मुझे camera coordinate system में पता हैं. कैमरा के x, y, z के लिहाज से, कैमरा origin के लिहाज से मुझे coordinates क्या होंगे? I know the location in 3D with respect to camera coordinate system. Yes.
सर ये जो आपने पहले इमेज प्लेन है, तो
Yes.
बेसिकली इमेज प्लेन कैमरा के अंदर हो गया,
Yes.
ठीक है? तो ये वाली एक्स वाई एक्सिस आपने कहा है ये कैमरा की एक्स वाई एक्सिस के साथ पैरेलल है,
Yes.
ठीक है? कैमरा के एक्स वाई एक्सिस और इसमें क्या फर्क है? मतलब ये इमेज प्लेन ही कैमरा के एक्स वाई एक्सिस नहीं होते?
Oh, it is a shifted plane. It is an x. So camera का एक xy plane है. इसी प्लेन का एक शिफ्टेड वर्जन है जो इसमें it is parallel to xy और ये f यूनिट्स अवे है.
ओके,
ये f यूनिट्स अवे है. इससे पास करेगा तो जैसे that distance between the center of the camera which is the pinhole and the image plane which is parallel to xy plane of the camera. This distance is called focal length.
बट सर मुझे ये समझ लग रही है कि अगर ये जो मतलब ये जो डिफरेंस है वो फोकल लेंथ का है,
Yes.
दोनों में ठीक हो गया, वो फोकल लेंथ का डिफरेंस हमारे पास पिन होल वो सेंटर का है, ठीक है?
सेंटर से इमेज प्लेन का डिस्टेंस.
हाँ जी, वो फोकल लेंथ आ गया, तो वो सेंटर है उसको मैं ऐसे अगर डब्बे को मैं घुमा भी दूँ
Yes. xy plane पर लाइन रहेगी. xy plane में लाइन रहेंगे. आप पूरा कैमरा घुमाएंगे ना जैसे मर्जी, तो जो कैमरे का xy प्लेन होगा वही इमेज का xy प्लेन होगा, क्योंकि इमेज कैमरे के अंदर कैमरा की स्पर्शी ओरिएंटेशन में आ गया. It will always remain parallel to xy plane of the camera.
बस कंफ्यूजन यहाँ पे आ रही है मुझे, जहाँ पे ये जो यहाँ सुराख है, जहाँ पे होल है जो,
Yes.
ठीक है? इस प्लेन के अंदर इस प्लेन को मैं थोड़ा सा टेढ़ा कर भी देता हूँ तो इसका क्या फर्क पड़ेगा? मतलब अगर अलाइनमेंट सही नहीं भी रहती तो इससे इमेज प्लेन पे तो कोई
No,
फर्क
no,
नहीं
no.
पड़ेगा।
The image plane is defined like यहाँ पे जो भी एक्सेस आपने फिक्स किए हैं ना, जो भी एक्सेस आपने फिक्स किए हैं कैमरा के ऊपर उसको जैसे मर्जी आप घुमा दो. At the end of the day you have to fix the x axis, y axis, z axis क्योंकि उसके लिहाज से आपने कोई 3D पॉइंट मेजर किया. उस x और y के लिहाज से image plane they are parallel. अगर वो पैरेलल नहीं है we may have to do some geometry to do that. ठीक है, फिलहाल they are parallel and they are constructed like that. Okay, so far so good. So I am assuming a point P in 3D. The coordinates of this point xc, yc, zc, c subscript for camera. The coordinates of this point, the x coordinate is xc, c means it is measured in camera coordinate system. The y coordinate of this point is yc, the z coordinate of this point is zc. Image के अंदर ये जो आपको रेड लाइन नजर आ रही है, so for example मैं origin से x1 units x axis में जाऊँ, फिर x2 units अगर मैं y axis में जाऊँ, और फिर मैं x3 units अगर मैं z axis में जाऊँ, I will reach this point. So technically मुझे यहाँ पे x1, x2, x3 लिखना चाहिए था इमेज के लिहाज से, लेकिन मैंने xc को x1 का हुआ है, yc को x2 का हुआ है, zc को x3 का हुआ है, just to be consistent with x, y, z. Clear?
Yes.
Yes, ma'am. So let's say this point is available in 3D and its coordinates are available in camera coordinate system. Yes? The camera center is 0, 0, 0. And the focal length of the camera, the distance between this plane and this center, that focal length is, let's say, f. Because the camera plane, because the image plane is parallel to camera and it is shifted f units away from the camera, the equation of image plane is z equals minus f. Is that okay?
Yes.
Because what is the equation of xy plane? The equation is z equals to 0. Everything with z coordinate 0 is on xy plane. If I shift that plane f units away in the negative z direction, the positive z direction is going out for the negative z direction, then every point with last coordinate minus f will lie on image plane. So the equation of the image plane, the restriction on the points. So what points lie on the image plane? The points with last coordinate z coordinate minus f. Yes? So the equation of the plane is, the only restriction is the z coordinate should be minus f, whatever xy coordinates are. So that's the equation of image plane. So equation of image plane is zc equals minus f. By zc means, again, the points on this plane, they are also measured in camera coordinate system. So जो यहाँ पे point होगा image में, उसका कोई x coordinate होगा, कोई y coordinate होगा, कोई z coordinate होगा. Z coordinate will always be minus f. X and y coordinate they will be according to जो भी इनका z coordinate will always be minus f. अगर मैं कैमरा origin के लिहाज से कैमरा coordinate system में इसको देखूँ, तो there will be x coordinate, y coordinate and z coordinate will be minus f. अगर मैं image origin के लिहाज से देखूँ, तो there will be an x coordinate, y coordinate will be the same as जो कि कैमरा में x और y coordinate थे. लेकिन z coordinate will be 0 because there is no z. Yes, no?
Yes.
Make sense? Now the question is, if the focal length is supplied, is given, and the 3D point, the coordinates are given in camera coordinate system,
XYZ.
XYZ. They are given in camera coordinate system. So they are measured from this origin along these axes. Then where this point will map at the image plane? I want to find out the location of this 3D point in the image. And this is the process of imaging, how a 3D point maps to 2D. Once we understand this imaging process, then we will be able to find out how we can reverse this process. How, given a 2D point, given a location of a point in 2D image, how can we find out, okay, in 3D it will be there. And if there are multiple points, for example, the points on my head, if they are given in image, can I find out that these head points in 3D, where are they? And then they will create a sphere or maybe like whatever the poster of that in the 3D image. So I need to know the imaging process to reverse it to find out the 3D points. Yes, no?
Yes.
Should I continue? Sakas?
Yes.
Okay, now because light travels in straight lines, the light emits from this point P, it will pass through O, which is a pinhole, and continue its journey in a linear fashion, and eventually it will hit this image plane at some point. That point is Q. We need to find out the coordinates of Q. Sahi hai ji? And you can see this Q is simply the intersection of this green line, which is line joined by P and O. If I join the point P with O, that's the line in 3D, and there is a plane in 3D, Z equals F. The intersection of this line and that plane is actually the point, the image point of that 3D point P. Yes, no?
Yes.
So far so good? So the rest of the story is, if we can find out the intersection of this line and this plane, then the point of intersection is basically where this point is located. For this point, the point of intersection is this. For this point, the point of intersection is this. For this point, the point of intersection is this. Different points in 3D, different point of intersections in 2D. Yes, no? So far so good?
Yes.
Okay. Now, how to make a line from 2 points? We have a point O in 3D. It's 0, 0, 0. We have a point P in 3D with coordinates XC, YC, and ZC. What is the line that passes through these points? Let's have the equation of that line. Once we have the equation of that line, we already have the equation of a plane. We will be able to find out the point of intersection of those. Yes? Okay. So, let's say we have a line, let's say we have a point A and we have a point B. Then the vector between A and B can be written in the following way: B minus A. That's a vector between A and B, where A is some point in 3D, B is some point in 3D. This is the vector between A and B. Whether in 3D, 2D, or ND, that's how we find out the vector between B and A. Yes? Now, that's a vector, 3 vector. If I always take the steps in this particular direction, starting from a point A, if I start my journey from point A, and I always take T steps in this direction, then I will stay on the line joined by these 2 points.
Yes.
So T might be negative, T might be positive. For example, if T is 100, I may end up here. If T is 50, I may end up here. If T is minus 100, I may end up here. But that's how I will always stay on the point defined by these 2 points. The line defined by these 2 points. Yes, no? No? Okay, I will read. Let's say A is a point and B is a point. Let me explain this in 2D, in more head-to-tail rule fashion. let's say this is x, this is y, this is some point A with position vector this, and this is some point B with position vector that, and this is the vector between A and B, B minus A. Okay. So if I scale this vector B minus A, let's say with 100, I will get a vector of much larger length. Yes? I've scaled this. Now, if I start from origin, I reach at A, and then from A, I reach here. Then from origin, I reach at a point that is on this line. Make sense? So I start from A. So I start from origin, I reach A. Then I take t steps in this direction. So A plus this. By head-to-tail rule, this is this.
ये A plus B है, B minus A कैसे होगा?
Sorry?
B minus A ये कैसे आ गया?
A plus B minus A. This is B minus A. This vector is B minus A.
ये B minus A कैसे होगा?
If I have, so this is A, this is B, this is A,
But this is A.
this is B, this is A, this is B,
Hmm?
okay, and A plus B जो है वो तो शायद ये है, so A plus B is something else. Let me write A plus B. So if this is A and this is B, I can write on B, I can write this as A
Yes,
plus, this is A plus B.
Yes.
This is A plus B.
हाँ, A minus B तो B minus A जो है वो तो उल्टा करेंगे ना, right? B minus A इस पे एक इसके इस तरफ ले जाऊंगा, right?
ऐसे?
नहीं उस साइड पे. B जहाँ end हो रहा है उस साइड पे नीचे आएगा ना?
Yes. Okay. So this is.
Oh, okay. So they are parallel. Yes. नीचे आएगा, वो नीचे की तरफ आएगा और वो उसके पैरेलल होगा.
और वो पोजीशन वेक्टर नहीं होता, उसको कहते हैं फ्री वेक्टर. उसको आप जिधर मर्जी ले जाएं. I mean, once you have this, you pick it. As long as you keep its direction and magnitude fixed, you can move it anywhere.
Yeah.
It's a free vector.
But this.
So yes.
But उसी से ही आएगा.
यहाँ पे आएगा.
Yes. और वो.
यहाँ पे आया, यहाँ पे क्यों नहीं आया? That's a free vector. इसको जहाँ मर्जी लेके जाए, that's the same vector.
सही है.
This is the position vector that is fixed. Its one end is fixed.
Right.
See?
Makes sense.
Okay, so is that okay that this is B minus A? And you scale it with, let's say, 100. And then you're here. And so if you scale it with another number, by this formula you will stay on the line defined by these 2 points. Is that okay?
ठीक है.
So similarly in field. Similarly, by the way, we are interested in 3D lines. So yes? Okay. So let me define this. I can open up this by just a simple mapping minus t times a, where t is a real number. I can write this as 1 minus t times a plus tb. That's a new point on the line parameterized by t. So you supply me the value of t, I will give you a point on the line. You give me another t, I will give you another point on the line, and so on.
Yes.
Yes, no?
Yes.
So अगर आप चाहते हैं कि सारे के सारे points आप generate कर लें इस line के,
T को
exhaust all t's.
Yes.
So इसको funny way में आप ऐसे कह सकते हैं, अगर आप ऐसा loop लिख सकते हैं जो t की all values के iterate कर ले, for every iteration will give you a point. Yes? Okay. So having different values of t, I will move on the line. So t this, I'm here, t this, I'm here, and so on. So the equation of the line is the following. Is that okay? This is the equation of the line, defined by point O and point P, where O is 0, 0, 0, and P is x, c, y, c, and z. So far so good? So समझ आ रही? आपको तो ये लास्ट टाइम भी हो गया था, तो उनके लिए मैं दोबारा कर दूँगा, लेकिन मुझे समझ नहीं आ रही बताएं. Is that okay? Okay. This point O is 0, 0, 0, so the line ends up to be t times p, which is t times, so the x coordinate of the line, so any point that is on the line has this x coordinate, the y coordinate is, and the z coordinate is t times c. This is point on the line. You change t, you get different. By the way, ये zero add होगा इसमें. Yes? Make sense? Now, there is a plane जिसके ऊपर जो भी points हैं, उनका third coordinate ये है. I want to find out a point on the line that is also point on the plane. That's how intersection is.
Yes.
Point of a point, and by the way, in this case, that point is unique
Yes.
because the line is not in the plane. That point is unique. Okay. So you walk on the line until you reach the point. A point पर reach करने के लिए all you have to play with is t. Change the t so that you stay on. Whenever you change the t, you will stay on the line, but stay on the line as well as on the point, as well as on the plane. मैं t की क्या वैल्यू लूँ कि मैं प्लेन पे पहुंच जाऊँ? याद रखें t की जो भी वैल्यू लेंगे आप लाइन पे तो रहेंगे,
हाँ.
पर t की वो वैल्यू जो आपको प्लेन पे भी ले जाए. याद रखें t की वो वैल्यू जो लाइन के ऊपर जो पॉइंट है उसके थर्ड कोऑर्डिनेट को -f कर दे.
अच्छा.
अगर आप लाइन के ऊपर मूव करते रहें, लाइन के ऊपर मूव करते रहें, लाइन के पॉइंट्स हैं काफी सारे, लाइन का वो पॉइंट जिसका थर्ड कोऑर्डिनेट -f है, वही वो पॉइंट है जो लाइन पे भी है और प्लेन पे भी है. Yes, no? Yes. So basically I want t that makes the third coordinate of the point on the line to be -f, because that's the point of intersection of the plane and the line. Is that okay? Yes, no? Okay, so that means I want this number to become -f.
Yes.
Such a t is required, and that t is -f over zc. If I choose this t, obviously if I choose any t, I'm on the line. If I choose this t, I am on the line, but at the same time I'm on the plane. So with respect to this t, what is that point? Let's plug in this t here and here. So that point is basically -fxc over zc. This is the x coordinate of the point.
Yes.
Y coordinate of the point is yc over zc. And the z coordinate of that point
Is -f. Perfect.
Yes? Yes. Now these are the
No.
coordinates.
No, sir. You need somebody.
You know,
Yes, sir.
plug in the value of t here and plug in the value of t here.
-f over GC.
-f over zc. So the point on the line, that is also the point on the plane, it has x coordinate as -fxc over zc. It has y coordinate as -fyc over zc, and it has z coordinate as -f. Yes?
बेहतरीन.
Now, by the way, this point is here q. The coordinates of q is now reported from the camera coordinate system. That's why the third coordinate is there. If I measure the same point with respect to the image coordinate system, then the third value is dropped and the first two values are unchanged because the planes are parallel, and जो लाइन उसके origin से पास कर रही है वो इस plane को जहाँ पे hit कर रही है, that is defined by the origin. Origin is not shifted either.
नहीं सुना.
Yes, no? दोबारा से देखें. ये xy plane. Let's say this is xy plane. Just assume. Let's say this is y and this is x. That's it. This is the origin. That's it. Of image plane. That's it. This is negative y. This is the xy plane. This is the xy plane of the camera.
अच्छा.
And Z axis passing through origin, and the same is passing through this origin.
अच्छा
And it is orthogonal to that.
हम्म
Now, any point, because any point that is on this plane, for example, on the location 5, 7, 0, this is exactly on this plane at 5, 7 with Z0. नहीं?
मुझे समझ नहीं आई क्या
नहीं, मैं ये कहने की कोशिश कर रहा हूँ कि जो XY प्लेन है कैमरा का,
अच्छा
XY प्लेन है कैमरा का, उसको मैंने शिफ्ट करके पीछे कर दिया ऐसे,
अच्छा
तो फर्ज करें मैंने उसकी एक कॉपी बना दी, उसकी एक कॉपी बना दी, ठीक है क्या? तो इस कैमरा के अंदर अगर कोई पॉइंट है, यानी कैमरा कोऑर्डिनेट सिस्टम में अगर कोई पॉइंट है जिसका कोई x और y कोऑर्डिनेट है, इस प्लेन के अंदर जिसका x और y कोऑर्डिनेट वही रहेगा उस पॉइंट का।
अच्छा ठीक है
z कोऑर्डिनेट फर्क आएगा,
बिल्कुल ठीक बात
x y कोऑर्डिनेट हैज टू स्टे द सेम
यस
because this is a shifted version of x y plane of the camera.
ओके
Yes? And z coordinate on this plane is no longer required because in the image there is no third dimension and that can be drawn. अगर आप धक्के से कैमरा कोऑर्डिनेट सिस्टम में ही मेजर करना चाहें तो all the points of the image they have z coordinate minus f. Still can be drawn. It is same for every point. Yes, no. So camera is the imaging device that maps this point, which is available in camera coordinate system, and it is available in camera coordinate system, to this point, which is now available in image coordinate system by the assumption that the optical axis, it passes through, wherever it passes through the image plane, that point acts as origin. Yes, no.
बेहतरीन
So far, so good?
यस
If this slide is okay, I should move on. Homogeneous coordinates. If you are given, for example, a point in 2D, you can represent the same point in homogeneous coordinates by choosing a value, scale factor, non-zero scale factor. Point Z is 3, then this is 3x, 3y, then 3. Another student may come up with a scale factor, let's say 7, and this becomes 7x, 7y, and 7. Another student may come up with minus 2 over 3, the scale factor, and this becomes minus 2 over 3x, minus 2 over 3y, and minus 2 over 3. So one point in 2D, they have several homogeneous representations. Whatever homogeneous representation of a point you come up with, when you convert back, you get the same point. Make sense?
Yes.
So one common way to represent a point in homogeneous coordinates is just to choose a scale factor 1. So just, converting to homogeneous coordinates is easy, and back conversion is easy. Why do we need homogeneous coordinates? It actually simplifies a lot of math. A lot of transformations that are not linear in original coordinates, they sometimes become linear when we use homogeneous coordinates. And the cost of paying to convert homogeneous coordinates from the coordinates to homogeneous coordinates is negligible. So several times ऐसा होता है कि आप original coordinates में बैठे हैं, the transformation that you do is no longer linear. By linear, right now the linear transformations are easy to perform. Non-linear transformations are sometimes difficult to perform. But just changing these coordinates from Cartesian to homogeneous coordinates, all of a sudden the transformation becomes linear. It achieves the effect that it has to achieve, but it achieves in a very linear way. It's a very easy way. Make sense? So it simplifies the math.
Sir, if it is 0 then we will reach a region of the camera.
Sorry?
There is a pin also. If we select the key 0.
So zero scale factor is not allowed to choose. Because if you choose a zero scale factor, then no matter what point you come up with, you reach at 0, 0, 0, and back conversion is not possible.
Yes.
Yes. Yet in homogeneous coordinates there are represent homogeneous coordinates. They can represent certain points that are not easily representable by Cartesian coordinates. For example, if this is a homogeneous representation of a point in 2D, this point, I mean, you cannot convert it back. The representation of that point in 2D is not available. But this is the representation of a point in homogeneous form, and this point is the following. Let's say this is the point 2, 3, and this 0 says, keep on walking in this direction until you reach infinity. So this is the point at infinity in this direction. And for example, आप plane के अंदर जितने भी finite points हैं, उनको तो आप represent कर सकते हैं दो नंबरों से ना. What if you walk in a particular direction and keep on walking and you reach at some point at infinity? There is no way to represent that point in Cartesian coordinates. And the homogeneous coordinates, they have a very compact representation of those points. These are the ideal points, the points at infinity. For example, this 5, 0, 0, this is a point at infinity in x-axis t direction. So in every direction, you can move in every direction infinitely many steps, and you reach at a point that can be represented in homogeneous coordinates by appending the last coordinate 0. The only exception is this. This is a point that has no meaning at all. 0, 0, 0. Because 0, 0 is not a direction in which you have moved infinitely. Yes, no?
Yes.
Why these points at infinity, they are important. We will see later on that the camera, it has power to image those points as well. The points that are located at infinity, the camera just project it into a finite place. We'll see that. Yes? Okay. Anyways, the imaging device has to do the following. It is given this point XC, YC, and ZC. And it is also given F, the focal length, and it has to generate these points. That is a valid imaging process. Yes? And now you can see if I convert this point to homogeneous coordinates and I multiply it with the following matrix that I have constructed somehow, the result will be this. And if I convert this point to non-homogeneous back, I convert this point to homogeneous. Whatever I do, I stay in homogeneous coordinates. I get this result. I convert this back to non-homogeneous. I get this result. Yes? How can I convert this to back to non-homogeneous? I pick the last coordinate. I divide by that, and I throw it out. So now you can see mapping from this point to this and then converting just to non-homogeneous is what the camera does. Yes, no?
Yes.
So camera is essentially, what the camera is doing is essentially this matrix multiplication. This is all what the camera is doing. How it is mapping a 3D point to 2D is by multiplying this matrix at the end of the day. And this is called camera matrix. By the way, ये जिस जगह पे point को map कर रहा है उस जगह पे intensity क्या होनी है? This is not the topic today. All am I saying which position goes to which position, regardless of its intensity. Yes, no. Yes.
पर जब भी आपने जीरो की बात की, आप उसमें मल्टीप्लाई करवा दो कि इंफिनिटी से कैसे लेके जाएंगे?
Multiply करवा दो.
जी आपने कहा था ना वो 2 3 0 लिखा ही इंफिनिटी पे होगा पॉइंट.
No. This is one way of representing points at infinity. I'm not justifying कि आप actually इससे actually divide करेंगे आगे. और फिर वो divide करने के बाद आप infinity पे पहुंच जाएंगे. This is one way of representing points. और इससे आगे जो पूरी इसकी प्रोजेक्टिव ज्योमेट्री है, पूरी मैथ है, जो बिल्कुल जस्टिफाई करती है कि एक्चुअली दिस इज द पॉइंट एट इंफिनिटी और इसको यूज करेंगे कि यहाँ पे आएगा वगैरह. Make sense? I'm not saying that you actually go and divide this by 0 and divide this by 0 and see whether these are infinities or not. I'm not saying that.
ये इसलिए जीरो ना कि जी से डिवाइड होना है जाके और फिर से.
You can call it analogously to that, but I don't see कि exact 0 से divide होके infinity देगा या नहीं देगा. If if you get very large number, you have to divide by very small number, eventually not zero, limits and stuff like that. This is a way to represent the points at infinity. The analogy जो आप build करना चाहते हैं, this is easy to build the analogy, divide by zero, infinity, divide by, but this is not exactly what happens.
अच्छा.
So append the last zero, and this is the point at infinity. Just to, all these points at infinity, they satisfy a linear equation. So there is a line that all these points lie on, and that is called line at infinity. And this is very strange. In plane, you walk here, you walk there, you walk there. It looks like that the points at infinity, they are in a sphere. It looks like they surround everything as a circle. But at the end of the day, they lie on the line. So these are difficult things to imagine, very difficult. But the math works very beautifully, and no axiom violation, nothing. So they represent in this way that's a complete new math called projective geometry. They build that regardless of their intuitions. They simplify every function in linear form and they do stuff and they go back to Cartesian coordinates. And these points, they represent point at infinity and they have their own math, which we will see later on. Clear? But considering that this zero, I divide by zero and get infinity is, I don't see that's the analogy.
अच्छा.
So far so good?
Yes.
This is the camera matrix. So अगर मैं आपको एक पॉइंट दूँ 3D में जो कैमरा कोऑर्डिनेट सिस्टम में मेजर्ड है, अगर मैं आपको कैमरा की फोकल लेंथ दूँ तो आप मुझे बहुत आसानी से इमेज के अंदर उसके x और y कोऑर्डिनेट्स बता सकते हैं.
बिल्कुल ठीक बात.
And the equation is this, just multiply with this matrix.
बस.
Construct a matrix, multiply it. हाँ, जब जवाब आए उसको नॉन होमोजेनियस फॉर्म में कन्वर्ट कर. क्योंकि ओरिजिनल पॉइंट को आपको होमोजेनियस में कन्वर्ट किया होता ना. So you are in homogeneous until you black convert it. सही है जी? Yes.
सर तो हमें पॉइंट ऑफ फोकस गिवन है तो हम वहाँ से क्यों निकाल रहे हैं?
अगर मैं कहाँ से वो डायरेक्ट मैं वही कह रहा हूँ कि this matrix multiplication is exactly what we did so far. So आप इतनी मैथमेटिक्स से गुजर के जिस जगह पे पहुँचे हैं that ends up to be a matrix multiplication. That's what I'm trying to say.
मुझे ये बात समझ नहीं आई, आप दोबारा होमोजेनियस में जाने वाली क्या बात कर रहे थे?
So आपने स्टार्ट करना 3D पॉइंट को होमोजेनियस फॉर्म में कन्वर्ट किया.
अच्छा.
So जो रिजल्ट आया it is still homogeneous.
अच्छा.
उसको नॉन होमोजेनियस में कन्वर्ट करना पड़ेगा. So there is a scale factor that is there.
अच्छा.
Make sense? और उसकी वजह मैं बता दूँ आपको. उसकी वजह ये है कि ये कैमरा मैट्रिक्स है एक्सेस सी इसको मैंने एक पॉइंट से मल्टीप्लाई किया, I'm calling it P. सही है? और मेरे पास कोई जवाब आ गया let's say P डैश. सही है?
ठीक है.
इस P को पूरे के पूरे को मैं जिस मर्जी स्केल फैक्टर से वो कर दूँ, मल्टीप्लाई कर दूँ. It is same point at the end of the day. लेकिन ये रिजल्ट क्या है कि लैम्डा से मल्टीप्लाई हो जाएगा. So जब तक मैं homogeneous form में हूँ, the result is also in homogeneous form. I have to back convert it to lock it to the Cartesian point.
अच्छा.
Make sense? So ऐसा नहीं है कि मैंने original point को homogeneous form में convert कर दिया, matrix से multiply किया, अब जो जवाब आया वो automatically Cartesians में. No, वो homogeneous नहीं है. We have to convert it back to get the exact location in 2D. And how we back convert it? We choose the last coordinate, we divide it by it, and then we throw. Yes, no? Okay. So far so good?
Yes.
We assume so far that our image origin is this point, which is the intersection of optical axes and the image plane. Sometimes this point is called principal point. Say it? It is common, however, to standardize the origin at some other point. हो सकता है कि कैमरा मैन्युफैक्चरर्स ने कोई ऑप्टिकल एक्सिस उनका और जो इमेज प्लेन है वो बिल्कुल सेंटर में नहीं आ रहा, किसी पे कहीं आ रहा है, किसी पे कहीं आ रहा है, so on. And इम्प्लीमेंटेशन के हवाले से भी शायद हमें ये ज़्यादा बेहतर लगता है कि अगर हमें 2D array गिवन है और हमें उस पर प्रोसेस करना है, so let's treat this point as origin and everything going outwards. For example, जो indices बढ़ते हैं वो इस साइड पे बढ़ते हैं और इस साइड पे बढ़ते हैं, that is common practice in arrays. सही है? So क्या कैमरे के अंदर ये फैसिलिटी दी जा सकती है कि whenever I want to change my origin, I can change it? Obviously, अगर मैं ऑप्टिकल एक्सिस और इमेज प्लेन का इंटरसेक्शन पॉइंट को प्रिंसिपल पॉइंट यानी उसी को ओरिजिन ले लूँ, आई हैव द मैथ सो फार, कैन आई रिलैक्स इट, कैन आई हैव द एबिलिटी टू चूज ओरिजिन द वे आई लाइक. फॉर एग्जांपल मैं ओरिजिन चूज करना चाहता हूँ 5,7 दिस पॉइंट एक्ट्स एज ओरिजिन. द क्वेश्चन व्हाई यू वांट दिस, ओके I may need this due to the implementation details to make the standardization game. Always the image origin will be treated as a top left corner or stuff like that. But the question is, can I do that? Why I want to do that? There might be several reasons to do that. Can I do that? That's an important question. Make sense? The principal point is fixed. When you construct the camera, the optical axis and the image plane, they have a fixed intersection and that has to stay fixed. That's the image origin so far. Can I use another point and treat that point as my image origin? All the coordinates of every point, it looks like they are measured from that point. मैं बताना ये चाहता कि ये कोई So assume the camera is the following thing. It accepts a 3D point, let's say XC, YC and ZC, and it accepts this and light intensity and light. It also knows the location and the lightest scenario is done. And camera eventually gives me the following: intensity at the sensor and X location and Y location in the image. Make sense? This is the 3D coordinates of a point along with the light. The light इस जगह पे हिट करेगी और इतनी हिट करेगी intensity. That's what the camera does. Make sense? अगर मैं कैमरा ओरिजिन प्रिंसिपल पॉइंट चूज करता हूँ तो दिस लोकेशन अपीयर्स. अगर मैं कोई और लोकेशन को चूज कर लूँ कि all the coordinates they should be measured from this particular point in the camera, in the image plane. अगर मैं कोई और पॉइंट ले लूँ, this point should act as origin. Then intensity तो वही रहेगी, उस पॉइंट की लोकेशन चेंज हो जाएगी, x and y they should change. Make sense?
Yes.
Yes, no. Now the question is, how can I do this? How can I do this? For example, जो fixed origin है वो तो fixed है, R is 0, 0. Let's say I want to choose this point, जिसके fixed origin के लिहाज से इसके coordinates हैं -px and -py. I'm assuming that this is R, the fixed origin R, and there is some other point, let's say this point, which I'm calling image origin or the new image origin. इस फिक्स्ड कोऑर्डिनेट सिस्टम, इस फिक्स्ड ओरिजिन के लिहाज से जो इसके कोऑर्डिनेट्स हैं they are -px and -py. Make sense? Assume करें कि प्रिंसिपल पॉइंट के लिहाज से यानी इस पॉइंट के लिहाज से I am given a point जिसके कोऑर्डिनेट्स हैं fxc over zc and -fyc over zc. This is some point. Measured from R.
अच्छा.
Can I measure the same point from this? जिसकी अपनी लोकेशन मुझे फिक्स्ड ओरिजिन के लिहाज से पता है. So I want to make this point as my origin. I want to measure these two numbers with respect to this origin. Axes are not changed. Axes वही है जो x axis y axis थे. They are the same. Only the position is changed. Can I do that?
तो इन एज लाइन
सो शायद आप इस नतीजे पे पहुंच गए कि स्टार्ट फ्रॉम हियर, रीच एट आर, देन फ्रॉम आर रीच देयर, एंड दैट्स द, सो यहाँ से यहाँ तक कैसे जाएंगे? by adding px and py.
हाँ
So px plus minus fxc over zc plus
Yes.
px
Yes, sir.
and minus fyc over zc plus py. These are the coordinates measured from this point, जिसके अपने coordinates fixed origin के लिहाज से पता है।
ऐड करेंगे माइनस प्लस
प्लस करेंगे। मैंने सिंपलिसिटी के लिए ना मैंने उसके साथ ऑलरेडी माइनस लगा दिया था ताकि इसमें ऐड करना पड़े। अगर उसके कोऑर्डिनेट्स अपने जो हैं, अगर उसके अपने कोऑर्डिनेट्स ये हैं तो यहाँ पे माइनस कर लें। ये डायरेक्शन रिवर्स करनी है आपको यार, ठीक है? तो मैंने सिंपलिसिटी के लिए यहाँ पे माइनस लगा दिया कि इसके अपने जो कोऑर्डिनेट्स हैं। मेक सेंस? Sorry? I just want from here to here. मैं यहाँ से यहाँ तक जाऊँगा। So R के कोऑर्डिनेट्स क्यूब इसके लिहाज से हैं px py, इसके लिहाज से इसके कोऑर्डिनेट्स, इसके लिहाज से इसके कोऑर्डिनेट्स हैं माइनस px माइनस py। सही है? अब अगर मैंने यहाँ पे पहुँचना है from here, I will reach there, then I will reach there। सही है?
बस
दोनों पॉइंट्स कैमरा प्लेन पे।
ये दोनों पॉइंट्स क्या मतलब है? ये भी अगर, और ये ग्रेड मैंने इसलिए बनाया बाय द वे, अगर मैंने इस पॉइंट को इसके लिहाज से मेजर करना हो, आई कैन डू दिस। अगर मैंने इस पॉइंट को इसके लिहाज से मेजर करना हो, आई कैन डू दिस, एज लॉन्ग एज द एक्सिस स्टे फिक्स्ड।
सर ये सारा इमेज प्लेन पे नहीं होगा?
इमेज प्लेन पे, हर चीज इमेज प्लेन। जो नया ओरिजिन है वो भी इमेज प्लेन के अंदर ही है। But I want that point to be very standard point कि जब भी मैं किसी को इमेज दूं, it is